devices. Obviously, a lot of work has had to happen around power management. We've always had power management on the server, because obviously it's important these days with all of the green initiatives to make sure that we're using resources efficiently in the data center. But it's a much harder problem doing it on a laptop, where every few percent of battery life is critical, because people really notice it if you take 5% of the lifetime of the battery. So there's a lot of work going on to optimize the power management on the platform, and there will be more extensions to come of optimizing things like the Xen scheduler to be more aware of what's happening in the platform. But also support for other kinds of devices. Obviously, there's the great work on USB that's being done by Fujitsu, but also things like Wi-Fi, wireless, wide area networks, and also doing graphics virtualization. There's been a lot of work to enable things like graphics pass-through. And also making sure that we have support for all the latest client platform technologies. So obviously things like the IOMMU, VTDs, so that we can do the PCI device pass-through, but also technologies like Intel's Trusted Execution Technology, TXT, so that we can securely boot the platform, so that we know that when the client hypervisor is booted, that we know exactly what code it is that we're running. We know that the hypervisor hasn't been tampered with, or any of the DOM0 components. And that's obviously key in a security context. There's also been work to shrink the hypervisor, or at least shrink the whole stack of software that's necessary to control the hypervisor. There have been versions of Xen Client which have been compressed down such that they fit in, I think the record was 8 megabytes for a working Xen installation. And that makes it small enough that you can actually embed it in flash memory. And that's certainly our vision for the Xen Client, is to ultimately have it embedded in flash memory on that system flash chip alongside the BIOS, ultimately on every laptop as it leaves the factory, or every desktop would have Xen Client embedded in it. And that's I think a very exciting possibility that we believe will start happening as soon as next year. So, what are obviously the use case for virtualization on client devices is very different from on server. Nobody cares about how many virtual machines you can consolidate onto a single laptop. It's a very different use case from on server. And the use cases really center around security, manageability, supportability, auditability. And a client hypervisor can really help with those problems. And just to give you a few examples, one of the things it enables you to do is to build a multi-level secure system. This is where you have multiple virtual machines running side by side, and by default, they are completely isolated from each other. And then by a policy, you actually enable some communication in a tightly controlled fashion. So you could have an example where you could have two virtual machines, one of which might be for your business use, contain all of your corporate data, and then you might have another virtual machine for personal use. You could have in a government environment, you might have one virtual machine containing top secret data, and another machine just containing the lower classification of secret. You can have virtual machines which are disposable, that you use for browsing the web when you're unsure of the sites that you're visiting. Or you could have another virtual machine which you dedicate to use just for doing internet banking. And having a trusted hypervisor enables you to provide that isolation. But also, the hypervisor provides a platform, and it's a platform which you can then add other components to actually perform out-of-band management and policy enforcement of what is going on in the various virtual machines. And there are a number of functions which today are implemented inside the guest operating system, which are actually better done outside as part of the hypervisor platform. So, for example, things like virus scanning, malware detection, remote access to the virtual machine, even updating of the guest operating system, backup, VPN access. All of these functions we believe are actually best performed on the hypervisor platform. So creating other virtual appliance or service VMs, as we call them, that implement these kind of functions. So to take an example, something like virus scanning. If you've got a virus scanner inside the guest operating system, if some zero-day exploit happens and you're vulnerable to it and you get exploited, then the first thing that exploit is probably going to do is to disable the virus scanner. So that even a few hours later, when the malware detection vendor has updated their database, that virus will not be detected because the virus scanner has been disabled. Whereas if you're doing the malware detection in this separate virtual machine, looking into the guest operating system, then the guest operating system may become compromised. There's nothing you can do to stop that. But at least when the service VM will not be compromised, and when the update is delivered to it, so it's now able to detect the virus, you'll be able to detect that the virtual machine is being compromised. And similarly, performing things like update of a guest operating system, it's quite hard to do within the guest. You have to have lots of agents downloading software and then trying to install the software to apply those updates to the guest operating system. Whereas things can go wrong if the power gets turned off at the wrong time, or you end up with updates that happen to run at the same time and conflict. And people find that doing software updates to laptops using all of these agents running inside the guest is a very hit and miss process that sometimes leaves the laptop in a broken state, and it can be very expensive to remediate and fix that. Whereas if we can use the hypervisor platform to pull down some new set of bits, of blocks, so that we can actually run the exact same disk image that was tested by someone in the data center, we can ensure the laptop updates to those exact same set of disk blocks, and do that atomically, and we're able to do that outside of the guest operating system, so that next time we reboot it, we'll boot into that new version. And that enables us to do that update process very robustly. But of course, all of this requires a true Type 1 hypervisor. The whole use case for virtualization here is around security. And this just would not be possible using a Type 2 virtual machine monitor. You need the strong isolation and security guarantees that only a bare-metal hypervisor like Xen can provide. And of course, Xen, being designed with security in mind for that cloud use case, turns out to be ideally suited to this kind of use. And so we think that we believe that Xen has a great future in this client virtualization space. So here's an example of a system running Xen client. So we have two virtual machines here. The personal, an example there, a personal virtual machine and a business virtual machine. And this is DOM 0, or the control domain, which we make as small and locked down as possible. And then we have one or more of these service VMs. And in the example, you you might be having a simple service VM to start with, which is just running the user interface for the platform. But over time, you'll see other service VMs implementing things like virus scanning, firewall,